Good morning, everybody. Happy Friday. Um, I've got some. Well, I think it'll be good news. I think you guys will like it. We're going to move on. There's actually two more sections in chapter 3 that we could have gotten to, but with with sort of the pace that we're moving at here, I want to make sure that we get to some of the other key stuff that's really going to be important for you guys for next year. So we're going to actually bypass the last two sections on chapter 3 and move right into chapter 4. Okay, so you can see here I have the actual book printout of page 293. I have it zoomed in, so hopefully you guys can see it a little bit better. But it is going to be kind of weird to look at. So if you want to have your books open to page 293 so you can kind of follow along, we do have to do, unfortunately, one day of just general review and recap of exponential functions and their properties. So you can literally see some of the basic stuff that we start with is just what the different types of exponential functions are. We've got regular old exponents like x squared. We've got square roots are exponents because you could turn it into a rational exponent. So the square root of x is also x to the 1/2. Anytime you have a fraction function, you could do the same thing. If your x is on the bottom, you can move it to the top, turn it into a -1, and stuff like that. Okay. So what we get into, and I'm not going to lie, the first 6 questions on today's assignment are very algebra 1 type concepts. They get kind of intense with some of the exponents that they give you, but the first 6 questions are going to look like the ones on the bottom of this page right here. Again, hopefully you can see that okay. It didn't copy the greatest, but hopefully, like I said, you can kind of see it. Some basic properties of exponents. Okay, so the first and the most basic property is anytime you have something to the 0 power, it means there are 0 of it, it's not even there. So anything to the 0 power is equivalent to 1 because you basically just remove it. A to the 0 power means that there's not an actual a there. So you get rid of the a, but you fill its spot with a 1. Okay, then we get into like bases. So if you have two things that have the same base, you can add their exponents together, which makes perfect sense. It's like having x to the second times x to the third. Well, that just means there's 5 total x's. X to the second means x times x. X to the third means x times x times x. So all in all, there's 5 x's in that situation. If you have like bases but on top and bottom of a fraction, then you get into cancellation. The bases will cancel each other. However many there's more on top or bottom will determine where the leftovers will be. But another way of thinking about that is you can subtract the exponents. So hopefully you can see that this is a to the x over a to the y becomes a to the x minus y. You just subtract their exponents. Then we get into powers of powers. This is a to the x to the y. Basically, all you do when you see powers outside of powers in parentheses is you distribute. You distribute the x and the outer exponent to the inner exponents, and you multiply them together. So it becomes a to the x times y. Here we have a times b, both raised to the x power. It's the same thing. You can distribute that x to both the a and the b. So it becomes a to the x, b to the x. No different when it's a part of a fraction. A to the x, or this starts out as a over b raised to the x, and it becomes a to the x over b to the x. And of course, the last one is negative exponents. We know that a negative exponent just means it's in the wrong spot. Okay? So, what your first 6 questions look like, I'm on page 294 now. Okay? What your first 6 questions are going to look like are going to be the problems on top of this page here, A through F. So it literally starts out, like I said, very algebra 1. 2 to the third, or excuse me, 2 squared times 2 to the third becomes 2 to the fifth, and 2 to the fifth is 32. So you'll want a calculator today because it does say to simplify, or actually I think it says to evaluate, to find the actual value of the expression. Okay, this one, 2 to the second times 2 to the negative third. Again, whenever there's like bases, you add their exponents, so the work's down here. It becomes 2 to the negative 1. If you move that 2 to the bottom of a fraction, it becomes 1/2. Part C is powers to powers, 3 squared cubed. Then you distribute and multiply the exponents. 3 times 2 is 6. 3 to the 6 is 729. For part D, now part D is really dumb the way that they show it, okay? Let me show you what I would do for part D instead of doing it the way that they did it. Okay, they have 1 over 3 raised to the negative second power. What I would simply do on this one, I'm going to pull it off to up here off to the side. I would distribute the negative 2, so it's 1 to the negative 2 over 3 to the negative 2. I don't even know what they got going on here. I don't even know what this is. All you have to do is switch these, right? Literally, they both have a negative exponent, so the 3 goes to the top, the 1 goes to the bottom, and then their exponents are positive, and then you can clearly see it's just 9 over 1, or 9. So part D, they just explained it in a really odd fashion. Kind of the same thing for part E. I don't really like the way they explain it. I would just say it's 3 squared over 3 cubed. The 2 3's on top cancel 2 of the 3's on bottom, leaving me with 1 3 on the bottom, or 1/3. Okay? The only other thing that's kind of an oddity is part F. It's 2 to the 1/2 times 3 to the 1/2. This is kind of a lesser used skill, so this is one you want to kind of pay attention to and be on the lookout for. If you have two things that are totally different, totally different real numbers, but they have the same exponent, you can basically undistribute that exponent, which is exactly what they did here. They pulled the 1/2 out so that they could actually put the 2 and the 3 together. So if you pull the 1/2 out, 2 times 3 is 6, then it's 6 to the 1/2, or the square root of 6. The reason you're able to do that is because they had the same exponent. So again, we're going to be pretty familiar with it. It's going to be pretty obvious, like on part C, you're going to know that when you have a power to power, you multiply. But the opposite of distributing a power in is undistributing a power out. And you can do that if they have the same exponent. Okay? So again, kind of a lesser used skill, but something we want to be on the lookout for. So this is part of your assignment today, is just evaluating exponential expressions. I know it seems incredibly simple, but like I said, the book problems are going to range from the very, very easy to some that are going to confuse you a little bit just because of how elaborate they get. So that's the first part of your assignment. The second part of your assignment is either making or identifying graphs of exponential functions, okay? So we're all pretty familiar, I'm sure, with the concept or idea that exponential curves increase steadily and then get increasing very fast, or vice versa. They decrease sort of really fast and then steadily over time. The unfortunate part is this, and I guess I do have some good news. Even though graphing is a big part of your assignment today, most of it is just matching. They'll tell you that this is a graph, and then, or they'll give you like 3 graphs and they'll give you 3 equations, and you just have to match them. The bad part about, or the unfortunate part about graphing is there's no shortcut for graphing exponential curves. The way you do it is by just plotting points. So you can see here in this table, they've taken the 3 functions, 2 to the x power, 2 to the negative x, 3 to the x, and all they did is literally plugged in -3 for x, solve for y, -2 for x, solve for y, -1, 0, 1, 2, 3, 4, and all they have is just a whole slew of ordered pairs. Okay? Sorry about that. I had to run and let our carpet cleaner guy into the house there. Okay, so like I said, or like I just left off there, basically all you do is you get a bunch of ordered pairs and you construct your graph. So on today's assignment, there's only, I think, 4 of them that I'm going to have you guys just kind of draw in your own coordinate plane, plug in a bunch of x values or a bunch of numbers for x, get the corresponding y values, turn it into, and you don't need to do 8 points. I would say if you do about 5 points and spread them out a little bit, you'll be just fine. But there's only 4 of them on today's assignment that you actually have to graph. So on the ones that you don't have to actually construct the graph, you just have to do matching. All you really got to do is pick a couple ordered pairs and make sure they mesh. So if you're trying to match, for instance, this function right here, y equals, or f of x equals 2 to the x power, all you do is plug in some real basic points. Plug in 0. When you plug in 0, you get 2 to the 0 power, which is 1. So that's the ordered pair, 0, 1. Well, you'll notice they all 3 go through 0, 1. So you just need to make sure you keep picking points. Plug in 1. Plug in 1 for x, you get 2 to the first power, which is 2. So how many of the other graphs have the ordered pair 1, 2? Well, it's only this one, right? So literally, it's just the ones that you have to do matching, it's just pick enough points to where you can feel comfortable that you know you've, by process of elimination, got the correct graph. Okay? So I'm pretty sure, yep, and that's really basically the extent of it. There's on page 296, there's some real elaborate descriptions of the graphs. So like the graph y equals a to the x power. It's this curve that goes through 0, 1. It increases very sharply. Its domain is all reals. Its range, the graph stays above 0. There's a y-intercept. It talks about end behavior as you go to the right. The graph's going up. As you go towards 0, the graph is going down. It's continuous 1 to 1. There's a lot of description stuff on page 296, but I don't think the actual assignment asks you to describe anything too elaborately or too extensively. So that's basically what this first section's all about, just kind of recapping and reviewing exponential functions and their properties. All right, so shoot me any questions that you have on the assignment, and I will either send out a clarification email today, or if there are a bulk of questions, I'll just wait till Monday and do the typical clarification video. All right, guys, have a great weekend, and I will talk to you guys next week.